Can you solve this calculus problem? Let me know the answer in the comments below. Are you ready? Let's go. So what we have here is we have f of x, and it looks like a piecewise function out here, different f of x values for different values of x. Okay, so we have determined the value of c, there's a c here, such that the function remains continuous. So we need continuity. So we are first going to determine what conditions that will satisfy this continuity here. So at -1, so limit x approaches -1 from the negative side of f of x needs to be equal to the limit of x approaches -1 from the positive side of the same f of x. So the limit, both directional limits have to be equal to each other. That needs to be equal to the function of -1. All right, so that is a condition of a continuity. So let's go ahead and see what our limit looks like from each direction. So let's take a look first at the limit of when x is less than equal to -1. So this is the limit x squared plus c, and x is approaching -1. It's less than equal to -1. So it's going to be from the negative side. All right, so here what we are going to do is, so we are going to substitute -1 in place of x squared. So that's going to give us -1 squared plus c. That's 1 plus c. So the limit as x approaches -1 from the negative side is 1 plus c. Okay, so let's try to find the limit from the other side. So the limit x approaches -1 from the positive side. From the positive side is going to be our square root of x plus 1. Okay, so in this case we can substitute here square root of -1 is approaching from the positive side. Okay, so what that means is it's going to be slightly, very slightly less than -1. So from the positive side plus 1. So I mean, it's very close to -1, but coming from the positive direction. So what that means is this is going to still be this is going to be equal to 0. Square root of 0 is 0, but coming from the positive side, so very tiny amount, so that's still going to be 0. So the step 3 is we're going to set these limits equal to each other. Okay, so we have 1 plus c, because in order for it to be continuous, the limits have to be equal to each other. So 1 plus c is equals 0. So then we subtract 1 from both sides. Then what that gives us is c equals -1. So that is our answer for the function to remain continuous. Let's look at it graphically what that means. So when x is less than equal to -1, we have x squared plus c. So, but let's just draw x squared first. X squared is going to look like this quadratic graph here, but it's less than or equal to, so we start from -1 and it's less going this direction. And then, of course, the other one, x is greater than -1, is going to be an open circle, but it's going to look like a square root function, square root of x plus 1. So you see very clearly here, if you were to add a c here as is given in the problem, x squared plus c, that c has to basically be equal to -1. That means it has to move the graph 1 unit downward in order for this to touch this and become continuous with this other graph. So it's going to be then be continuous with this other, if the c value is going to be -1, that is moving the graph 1 unit downward. Okay, so that's the graphical expression. Let me know if you have any questions in the comments below. I'll talk to you next week. Have a nice day. Bye.